Consider the sequence 21,870, 7,290, 2,430. What kind of sequence is this? Well, I'm either using repeated multiplication or repeated addition. These numbers are getting smaller as I move forward, right? This is a decreasing sequence, so I'm either adding negative numbers or I'm multiplying by fractions less than 1 or dividing by something. So let me look at two of these. I'm pretty sure that based on the gaps that I'm not adding the same value each time. So let's try and look at it in terms of a sequence. If I take 2430 and I divide that by 7290, I get 0.3 repeated. And in fact, if I take the 7290 and divide that by 21 and then 870, I also get 1/3 repeated. So I happen to know that that's the ratio of 1 to 3. It's 1/3. So what's happening as I move forward here is I am multiplying by 1/3. Each new term is 1/3 the size of its predecessor. So this is a geometric sequence. And it's not asking what the generator is. It doesn't ask for that, but I'm going to put this here. I'm multiplying by 1/3. That's unfortunate. Let me just use a dot. I'm multiplying by 1/3. Find the next three terms in the sequence. Well, if I take off my last one, right, the 2430, I can multiply by 1/3, but I can also just simply divide by 3. So if I divide by 3, I got 810. Divide by 3 is 270. Divide that by 3, I've got number 90. So, well, this is kind of cooked up that these are nice numbers like this, but you can see that the next three terms in this sequence would be 810, and then we would go to 270, and then we would go to the number 90, and it continues. Next it says write the explicit equation for this sequence. So in order for it to be the explicit equation, remember what has to happen is if I give it a term number, it gives me the value exactly. Part D is write the recursive definition. So we're going to start with the explicit definition. And actually, I do need the 0th term here if I want to do this the way we've discussed in class. So as I move forward, if I'm dividing by 3 to get the next one, divide by 3. If I want the 0th term, I need to multiply by 3. So I want to take this 21,870, and I want to multiply that by 3. And when I do it, I get a fairly large number, right? 65,610. 65,610. So that's my 0th term. So the explicit equation would look like this, right? The value of the sequence for any term number, a of n, is going to equal the 0th term, which is 65,610, times the common ratio, which is 1/3, raised to the nth power. So what I do is if I just keep changing the value of n, this is going to give me every single value in the sequence. So I know, for example, this is the first, second, third, fourth, fifth, and sixth. So my claim is if I put, for example, 5 into that explicit equation, it should give me 270. So let's verify that. So there's my 65,610, and I'm going to multiply that by I'll do the fraction this way. This will be 1/3, and I'll just raise that to the 5th power. And again, this should give me 270, and it does. So this explicit equation for this sequence, you tell it which term number you want, right? That's your input n. And once you tell it the term number, it reports back the value of that sequence at that point. The other way that we've just talked about defining sequences is this recursive definition. Remember, recursive definition always needs two things. It needs to know the 0th term, and it also needs to know how to move forward, how to get the next term. I'm sorry, not the 0th term. although you could use that. It needs one of the terms. And in this case, I've asked for what's the first term. So for this recursive definition, I'm just going to say, look, the first term is 21,870. You start there. And then this is how I read this. To get the next term in the sequence, you take the term that you're at and you multiply by 1/3. So this just says take the one that you're at, take the a sub n, and multiply it by 1/3. So if I want the next term in the sequence, all I'm doing is I'm taking the 21,870 and then just multiplying that by 1/3. And if I want the next one, I just take the one that I'm at and times it by 1/3. So every single time I'm just continuing to multiply by 1/3 to move forward. And seeing this and being able to read this like this is it's a good skill. But you can see the two parts, right? I start at 21,870, and to get to the next term, right, to get to the n plus 1 term, I take the term that I'm at and I simply multiply by 1/3. So extend it, you just multiply by 1/3 or divide by 3. That's question 2.